Let's talk about potato late blight. It's one of the most destructive plant diseases on the entire planet. For centuries, we've had a pretty standard playbook for fighting it. But what happens when the enemy you're fighting keeps changing the rules of the game? Today, we're going to dig into a huge shift in how we combat this threat, a move away from just detection to something much more like sophisticated intelligence.
Okay, so this is it. This is the big question facing growers and agronomists right now. The old strategies for late blight, they're becoming less and less reliable. And why? Because the pathogen itself, Phytophthora infestans, isn't one single static thing. It's a moving target, and it is constantly evolving.
This right here, this slide, represents the massive conceptual leap we all have to make. For decades, the most important question was pretty simple. Is the pathogen present? Yes or no? Now, that's just step one. The crucial, absolutely game-changing question has become, which version of the pathogen are we actually dealing with?
So yeah, simply knowing the enemy is at the gates just isn't enough anymore. Getting that positive test doesn't tell you if the fungicide you're about to spray will even work, or if that resistant potato variety you planted is, actually still resistant. The enemy has gotten a lot more complicated.
Think of it this way. You're not fighting a single type of soldier anymore. You're facing a whole army of specialized units. We call these clonal lineages, and each one can have different abilities. Some are more aggressive, some have figured out how to bypass a plant's defenses, and some have even developed resistance to our best chemical weapons.
So if the old plan is on its way out, what's the new one? Well, it's all about adding a brand new layer of information to how we make decisions. We're shifting from just detecting the enemy's presence to actively gathering intelligence on who they are and what they can do.
And that new layer has a name: population intelligence. This is the key concept for this whole explainer. It means we're no longer just saying, yep, blight is here. We're now able to say the specific EU43 lineage of blight is here, and we happen to know it has reduced sensitivity to this specific class of fungicides. See? That changes absolutely everything.
So how does this new strategy actually work in the field? It's a pretty straightforward three-step process. First, you confirm the inoculum is present. That's your trigger. Step 2, you identify the specific genotype that's floating around. And finally, the most important part, you use that intelligence to adapt your management plan on the fly.
So let's meet the main players in this story, Europe's most wanted, if you will. These are some of the key lineages being tracked right now. You've got EU36, kind of the dominant, aggressive brute. Then you have specialists like EU43 and EU46, who are experts at resisting fungicides. And then there's EU47, a real codebreaker, able to defeat specific resistance genes in the potato plants themselves. Each name is basically a shorthand for a very specific type of threat. Okay, let's put this into practice. We'll start with a case study all about fungicides. How does knowing the specific genotype that's in your field change which chemicals you decide to use?
Let's zero in on EU43. Research has shown, very clearly, that this particular lineage is less affected by manajapropamid, which is a super common and really important fungicide. Now, if EU43 is the dominant strain in your area, and your whole spray program is built around that chemical, you could be in serious trouble and not even know it.
And just look how quickly the situation on the ground can change. In 2023, EU43 made up almost a quarter of all the samples in Europe. Just 1 year later, that dropped to only 9%. This kind of volatility shows exactly why you can't rely on last year's data. The pathogen population is constantly shifting, probably in direct response to what we're spraying. This quote just nails the whole point. Population intelligence isn't about giving you a perfect, fixed answer. It's more like a warning system. It tells an agronomist which of their assumptions are no longer safe, like the assumption that a trusted fungicide is always going to work like it used to.
But this intelligence isn't just about chemicals. Not at all. Let's look at another case study, how it completely changes our understanding of a plant's own built-in defenses.
We have a tendency to think of a variety's resistance as this permanent, fixed feature. The catalog says a potato variety is resistant, so we just assume it is. But the reality is so much more complicated. A variety is only resistant relative to the specific pathogen population it's up against. If that population changes, that resistance can basically disappear overnight. And here is a perfect and kinda scary example. The newly identified EU47 lineage has evolved the ability to defeat potato varieties that rely on the R8 and R9 resistance genes for their protection. So, a grower who thinks they're safe because they planted an R8 variety might be in for a nasty surprise if EU47 moves into their neighborhood. The plant's genetic lock has just been picked.
When you put all this together, you arrive at one inescapable conclusion. This is not a problem you solve just once. We are locked in a constant biological arms race, and that means our surveillance, our intelligence gathering, has to be continuous. We can't let our guard down.
This snapshot from early 2025 shows just how messy the battlefield really is. It's not one enemy. You have multiple lineages all coexisting. One might be dominant, sure, but you've got these other strains with dangerous resistance traits that are still present, lurking. This complex, shifting mix of threats, this is the new normal.
And that's why a genotype map from 1 year is just that, a snapshot in time. It's useful, but it has an expiration date. As soon as we change our fungicides or plant different varieties, we're applying new pressure. And you can bet the pathogen population is going to adapt. The enemy evolves in response to our every single move.
So what does this all mean for the future of farming? Well, we're moving away from fixed, rigid rules and toward a much more flexible system that's based on up-to-the-minute information. The next generation of decision-making has to integrate everything: weather data, inoculum detection, and this critical population intelligence. It's the only path forward to making truly adaptive and effective decisions.
And this brings us to one last big question. As all the challenges in agriculture, from new diseases to climate change, get more and more complex, more dynamic, is this kind of sophisticated, real-time intelligence becoming our single most vital tool for success and maybe even for survival?